Hello, everyone. Two more lectures on inheritance. Maybe more if I added more. Then we're going to look at polymorphism. Then we're going to go and start reviewing some stuff before we try and get to the second midterm exam. So let's actually get going here. Hopefully, we'll not have the same flickering effect that I had last time. I like to put in this. This was a slide I put in for last term. Leaving it in there on purpose. Uh, just because, although things from last term I had wanted to address things from last term directly, for all I know, they might be the same things for this term, and I like to point this out early on. So, first of all, people last winter term were complaining, were saying, "Oh my gosh, this is so difficult to deal with." I think they were using graphs instead of trees, and they thought that the assignment was ridiculously hard and stuff like that. And one of my big things is I don't like necessarily being a jerk. Well, actually, sometimes I do. Uh, when I say it takes you 2 weeks to do an assignment, if you do it the night beforehand, you should get caught with your pants down, right? It should hurt. If it's supposed to take 2 weeks, you should not be able to do it the night beforehand. I'm giving lots of warnings about the fact that this should not be done the night beforehand. You want to get this done and over with and asking questions as early as humanly possible so that we don't hit that particular situation. Do not want to be a jerk, but my big thing is easy assignments mean an impossible exam, right? We we need to cover over a certain amount of material. The exam is ultimately the way of showing that you actually understood and have sort of digested the material. So it needs to be at a certain difficulty level. Otherwise, subsequent courses are going to be sort of screwed over because we push you through without a knowledge of how to program. You get to the next class and you can't do it anymore. So, some of you might be doing the Viz class after this. You got to understand programming for the Viz class. Some of you have already done that Viz class. If you get to Chris Jocelyn's computer graphics class, or if you do any other programming classes, you will have to be able to understand how to code something from scratch. It is not meant you are expected to have known to already know when you get into the class. Uh, David Tui's he has a game development course, second year game development course. He was thrilled at what the students were able to do after taking 2400. I taught them 2400. They take David Tui's class, and then he was noticing that they were doing as good or better of a job than the fourth year students were doing in the more advanced game development class. He had a pretty high bar, and he had to really lower it down. He was very, he did not like the fact he had to lower the bar down or hold people's hands for a fourth year class. And yet the second year classes were able to pick it up and go. The amazing stuff that my second year class did last fall. So it would have been you guys after you take my class this coming winter term, you'd be taking many of the people that are doing media production and design, not media production and design. All the people that are doing any kind of interface and design work. Uh, if you're taking David Tui's class in the fall, Intro to Game Development, what I saw coming out of his class at the end. So I didn't get to see what I knew what my students were capable of after 2400. They got to David's class. They did final end of term projects. They made a game that everyone could see. I got to play them. They blew me away. The bar is extremely high after seeing what they were able to do last time. I need to get you up to that bar, right? Because everyone is expecting you to be up to that bar, but it's always very gratifying to see how amazing work that students can do when you give them the chance and you push them a little bit. So I don't want to make this necessarily easy. If we have problems, I'm more than happy to go over anything you want. Get path is actually something really difficult, but this would be very similar to the problem that you're going to have with printing the tree itself, especially when we get to assignment 3, which is object oriented programming for printing off the tree. That's going to require a lot more work because it's going to require recursion, and I'll go over some of that in our synchronous time together. I want to make sure that you see it because it's important that you get exposed to it. Even if you never use it later, knowing that it exists is kind of critical. We can slow down some of these parts, but we really don't want to slow down too much. I'm actually slowing down 2400 more and more every term, just trying to get to the right sweet spot of what I expect people to pop out with an intermediate programming experience and how much I can push you guys. So I'm going to try and slow down this first part of the term, do more time with object-oriented programming versus rushing through that and then slowing down at the end. So we're trying out a little bit of different tweaking of the course. So hopefully, please send me feedback, see what works, what doesn't. If you're still lost, let me know so we can make sure that you're on course. You are expected to ask for help. I am still shocked. I used to have, when I used to do office hours at Northeastern, I'd have lineups around, out the door. We'd have these large parties of people just coming in, asking about the assignments and asking questions or asking for clarification. They were very proactive in asking for help. And then I get here and nobody asks for anything. You all sort of stay quiet and then say, he didn't teach us anything. I'm like, go to the office hours. You're paying money for me to do office hours to help you guys. Come. I can't see you face to face, but I'm making sure that I want to make sure that you can ask any questions that you have. If you are doing anything else during these lectures, by the way, stop doing those other things during these lectures. Make sure that you're up to speed. Now, this is me slowing things down a little bit, but I want you to slow me down if we need extra clarification. That's what the synchronous lecture is for. But if you're watching the videos and trying to multitask, it will fail. If you're watching the videos and not doing any practical examples, you're going to have some troubles. The expectation for this class is I think it's at least 13 hours a week. There's about 3 hours worth of lecturing material. There's another 10 somehow for assignments, for labs, and the assignments shouldn't take you more than a couple hours. So assignments, labs, and just doing practice. Memorizing is not going to help you. So we already did the doubly linked list demo, so that's done and over with. Let's get to actually what we're covering this time. But I just wanted to make sure we covered this. Despite the fact that the problems are slightly different, the underlying problem is the same. Is that we're pushing you in the deep end. We're making you work for your degree program, as we should. This is not high school, and if my experiences with you guys from 1400 is any indication, I'm not expecting many problems. I'm telling you this before I even got to see you guys in action. I'm recording this in the summer, but I'm pretty sure anyone that was in my 1400 class last term, you're doing fine, right? You guys worked incredibly hard in 1400. Anyone that did my Viz class, you worked incredibly hard in my Viz class. Just keep it up. You got it. You got this. Okay, so today we're going to finish inheritance a little bit. Might be two classes, two lectures. And then we're going to look at destructors and constructor calls. And we'll have a little quiz on that, hopefully. This quizzes thing, I'm still trying to figure out how I'm going to synchronize it in the fall. We're also going to look at private, protected, and public. And so that's going to be a slightly different video. And we're not going to hit polymorphism, so we might as well scratch that sucker out. Okay, we're going to be hitting polymorphism next. And I'll give a hint at polymorphism when we talk about public, private, protected later on in this lecture series. Okay, so imagine we have a game. This is actually assignment 6 from the fall term for 2400. So you're dodging that bullet. I had a number of different objects you'd draw on the screen. So this model view controller assignment 5 that you're going to be doing in the near-ish future, it was assignment 3, assignment 4, assignment 5, assignment 3, assignment 4, and assignment 6, where I kept on building on the same project. At the very end, we were able to draw circles and squares and stuff like that on the screen. And then we had you draw animated images. So you can imagine an image on the screen is a sprite, like just what Donkey Kong looks like on the screen or what Mario looks like on the screen, like a two-dimensional image of something. And a game object may have a whole bunch of different images, let's say. Maybe they're non-animating. Maybe it's just a picture of a flower that you put on the screen, like in the old Mario, the original Nintendo Mario. Okay, if we had animating objects, what we have is we have a bunch of different images. We have an array of images. I don't know if you've ever seen what an animation properly looks like, but I'm assuming you have, where you have a bunch of images that are looking very similar to each other, and all we do is change from image to image to image. And if you do it fast enough, it looks like motion. That is what animation is. So we need an array of different frames, an array of different images that we're going to go through, cycle through. We have a frame rate we have the current frame, the current image that we're looking at. We may have a frame rate, how fast we animate through this. We could have a bunch of other things if we cycle through it, that sort of thing. But all an animated game object is just cycling through a whole bunch of images. Your one object just changes the image as it goes over time. Now, we could have all game objects have a bunch of animated images and only some of them have more than one image. We could do that. So non-animated images, game objects, and animated game objects are exactly the same, just one of them has one image versus a bunch. But imagine the simple, like a flower in Mario, is as complicated as a Goomba, is as complicated as Mario is. We have this huge amount of wasted memory because we have to keep all this extra overhead for animating images, all these extra functions, all these other possibilities where things can go wrong. All those functions can lead to problems. What we really want is we want the minimum amount of code, the minimum amount of functions and data for something simple like a flower being displayed on the screen. And if you want something that animates like a Goomba, that's the turtle from Mario if you didn't know. If you want an animated game object, well, then you add extra stuff. So you take your game object and you expand on it. That's what we're aiming for. The simplest thing, and then we build, when we want more complex, we extend the simple thing. So we have a linked list, which is the simplest form of a linked list, and a doubly linked list, which is takes linked list and adds a little bit of extra code to it. What another big thing is, and I love pointing this out, convoluted code ends up being hard to maintain. It also leads you open to problems. So if you don't expect people, if you have an image that doesn't have any animation, there are ways of breaking someone else's code because they did too general, for example. Or if you add functionality that you don't need, people can exploit it in other ways. I love pointing out the fact that smart fridges, there was a little while where people hacked people's smart fridges. Honest to God, they hacked smart fridges around the world and then turned them into spam bots. They were sending spam emails to the rest of the world through refrigerators, because the refrigerator, no one suspected that they had all this extra code, all this extra stuff in a smart fridge that wasn't being used, and people could exploit them, right? Because it was on the internet, because it was running Linux, and because you could do all this other stuff. They could make a spam bot out of a refrigerator. They used a thermometer in a casino to hack into the casino system. The thermometer in a fish tank, because it had a full Linux operating system underneath it all, they were able to hack the thermometer to hack into a casino. Right? These extra code means potentially extra problems. It's over engineered, it's over convoluted, over complex, and it's hard to actually. It leaves you open to exploits. So we're going to go simple, and then when we need complex, we extend the class and make something more complex. So with an animated game, what do we want? Well, I don't want to write the code twice. I want to write the game object code, have it work for just inanimate images on the screen, of like a flower being displayed on the screen. And when I want an animated image, I take that code and I just tweak it a little bit to make it better, to make it do more stuff. But only the animated objects have all of these different frames. Only the animated objects deal with timing events. Only the animated objects deal with maybe click events. I don't want to have all things do all, at some point in time, not every one of your objects can do all things. It's just overly convoluted. And if we have an array of game objects, what we're going to get to polymorphism later on. Ideally, what I want is just an array of game objects. I don't care what kind of game objects they are. They might be a flower, they might be an animating, it might be Mario, it might be an animating enemy, something like that. And I want to treat them all exactly the same and have them work the right way. They'll work differently despite being treated the exact same way. So, the idea here is, maybe I could put it in a different metaphor. You guys are all Carleton students. Some of you are BMPD students, some of you are IRM students, some of you are IMD students. IMD students, IRM students are, have different course requirements than BMPD students, for example. You all have different programs with different requirements, with different backgrounds, with different coming at it with a different skill set from one another. You're all Carleton students, though. I should be able to treat all of you as in the same as my students. Give you the exact same exams, but because your degree programs are different, maybe there's some little different tweaks in what your requirements are for passing the class. Maybe there's some slightly different tweaks when it comes to how you go about doing things or when you take the program. So BMPD students, a number of you, if not all of you, are taking it in second year, I do believe, for you guys, versus its first year for it's a beginning of second year for most IRM and IMD students. I think it's actually maybe to be third year for BMPD students, right? But I need to give you all the same exam. You have different backgrounds, different requirements for your program, so you're treated the same, but each one of you individually from different classes are going to have slightly different functionality. Things are going to be slightly different between you, but I want to treat you all the same, give it the same exam, but I don't. You shouldn't have the exact same requirements for your program. I want to have different classes, but you all have the same base class, which is Carleton student. That's what we're sort of aiming for here. We can also look at Pacman. So each one of those ghosts, the red, the pink, the blue, and the orange. I did not know this. My students knew this, and I did not. Each one of those ghosts has a different AI. I thought they were just different colors. No, they're not only different colors, they acted differently. Some of the ghosts are more aggressive than other ghosts. The answer is to have a generic enemy or ghost class, if you're doing it object oriented, one generic ghost class, and then each one of the different color ghosts, I'd have a different implementation, a different child class of the ghost class. So we could have 10 different orange ghosts, they would all act the same. 10 different red ghosts, they would all act the same. The, the color of the sprite is different, so they were going to be drawn differently. The AI is different, that's also going to be different. But a lot of things like can it go through a wall, that's in the generic ghost class. No, they cannot go through a wall unless they're dead and then they float through the wall, right? What happens when you eat a power pellet? All the ghosts are going to act exactly the same way. Uh, if Pac-Man touches a ghost, then Pac-Man dies unless it has a power pellet, right? All of these things are part of the generic ghost class, but there are some things that are unique to each of the different types of ghosts in Pac-Man. I also like to point out in Pac-Man, and I think the 1400 students got this last term, I love the fact that the number of levels it goes up to is, I think it's 1027, and the 128th level is gibberish and gobbledygook. I think it's that, or it's 250, 255 and 256. The reason is because it's actually using, it should be 255 if it's using an unsigned byte. It is using a byte of information to store what level it is, and then you overflow the byte of information and you get a gobbledygook level. The game Pac-Man actually stops when you get to a level that you cannot play because it becomes gibberish on the screen. I found that fascinating when I found that out. Anyways, so in summary for inheritance, we're so we have classes, but we also have subclasses. And a subclass takes what the parent has, the parent class has, and adds to it. It adds methods, it adds data. It can even change the methods and data. You're treated like your parent unless you say otherwise, effectively. And you can, very soon, we're going to find out that child classes can override the parent functions. So if I have a print method like I have in my linked list class, the doubly linked list class could have its own print method, which is going to be different than the other print method. There is an art, but this is hard. In case you think I just naturally, off the top of my head, come up with all of this stuff, I don't. It takes a lot of time and thinking and paper, quite frankly, to come up with how your data should be structured, how things should be organized, what should be in the base class, what should be in the child class, what should be in the grandchild class. How do I organize my data? Because there's not one right way of doing it. It's all decisions, and there's better ways of doing it, but not one right way of doing it. And so your job is to figure this out before you code. Because even when you do that, even when you think about it before you code, you're still going to have to make changes after you start coding. You're going to miss something, but it's a whole lot better than just blindly guessing and coding without thinking. So get out the paper, think it through before you start coding. Okay, so if you want a takeaway challenge, so we can say you can make a calendar, for example. Not an actual calendar you wouldn't see on the screen, but let's say a calendar of events. How could you organize? How can you make a calendar of events? Every event would be an object with a particular start and end time, for example. But what if some of those calendar events repeat? What if they're only available to me? What if some are urgent rather than others? What if I can be late for some? What if some are private only to me and not for other people? What if they're of different lengths so that they might overlap with other calendar events? What if it's just open-ended, like you working on an assignment? There's not a particular time when your thing has to be done. It has to be done this week or by this particular deadline, but the time you set aside for the assignment is not when the deadline is. It should be days, many days before the deadline, right? If you make a calendar system, how do you break down something that big and nasty? I have a bunch of calendar events. The base class is a calendar event, but what about repeat calendar events? Urgent calendar events? Is that just a flag? Do I have variable length ones? Do I have things that are hard? Maybe I have a flexible calendar event versus a calendar event which has a dedicated time and length. What's my base class? You're trying to figure out how you break this apart. So try and doodle it up. You don't have to code it. Doodle up how this thing would actually work. Take the time now. Just figure out how you would break this problem into little chunks. You'll realize just how difficult this is. There's an art form to how you organize and structure your data. The IRM people are well aware of this because that's what IRM is. Like any kind of records management is how you structure that data to find things. It's the same concept here. How do you structure your code so that it works in an intelligent way? Okay, so I'm going to take a mini break because we're going to revisit specifiers, and then we're going to go back over inheritance one last time. But I want to take a little mini break, so uh, just because I want to show this as a separate thing. So let's try that.